For the first session of the day, Alexey Zimarev is going to tell us if we need an event sourcing framework or not. Have fun.
I appreciate you all coming. 9 o'clock in the morning after the party, that's the worst time to give a talk. Like I said, someone needs to do it, so it will be me. I want to ask you some questions. There are not that many of you here, so we can have a bit of dialogue. How many of you know what event sourcing is? Good, that's my expectation. How many of you have built an application with event sourcing? Keep your hands up. How many of you run it in production? Good. That's cool, thank you very much. How many of you have had problems building event sourcing application? Okay, like everyone almost. So those of you who build it and never had any problems, you can just go. And anyway, I don't believe you, just, you know.
Define problems.
Define problems, exactly. The thing is, my journey with event sourcing started quite a long time ago, 7, 8 years. I went to Greg's course, and basically, almost right after, a couple of years later, I built my first event source application or system for production use with a team of about 20 people, me being an architect. First time officially taking this role. I have to say that application took a bit longer time to develop. I got lots of frustrated developers on my neck. The application finally went to production. It was pretty successful. But I would say that overall, in terms of developer experience and maintenance, it was a complete failure. But as a product, it was okay. So I learned some stuff, and I worked at other companies who built more event source application. Right now, I work as a developer advocate for Event Store, and I work as a chief architect for ABAX. It's a small company in Norway, about 300 people. And we track vehicles, mainly that's our business. And it's pretty complex domains with a high frequency or high level ingress and a lot of data processing. And in that company, after some time, managed to say, okay, shall we event source or not? Like, raise your hands, everyone raise their hands, and we go, right? As simple as that. And why? Because it took me as a champion and many other people in the organization, in the tech section of ABAX, to make it actually understandable and for developers to see the value in what they're doing. But those people who start this journey, I think they might stumble upon this. Want to learn event sourcing? Just use this function. Not that many likes, I have to say, but quite a few retweets. It's just a left fold, whatever it means. And then you see this. Have you seen this? Famous article, don't let internet do event sourcing is hard. You look inside the article and you find the diagram like this. And I did a Twitter rage about diagrams, event sourcing diagrams on the internet. I think it's horrific. And the horrific part is not that there are so many of them. They actually take it's the majority of the diagrams on the internet. If you look for event sourcing, they look like this. They're not that easy to find the correct implementation of event sourcing like it meant, originally known as distributed domain-driven design, where events actually business facts that need to be recorded in the event store and state reconstructed using left fold to make decisions upon it. I think there is a correlation between these diagrams being there and these articles coming out, and it's not coincidence that the only diagram in this article is the one on the left. This one, who knows what it is? Now I need to take it off. I'm not stripping, but it's getting hot. All right, can see that. But anyway, I will move. You will read it eventually. So I wouldn't name the vendor, but you recognize them. They actually promote their product to build event source applications as they see done right. What happens next? Like, how does it go? This is just a random slide deck I found in SlideShare this morning. We went with quite classic event sourcing CQRS stack. Command side with Kafka, event storage, or command side with Akka, event storage with Kafka, and query with Elasticsearch. Someone calls that classic. I mean, maybe I'm in a bubble, right? But I never seen anyone doing this. And I would never, in my wildest dreams, call it classic. But some people do. What happens next? Building the system went really well. They actually got it, so they produce events, they're probably business events, they put it in they execute a command, they put it in Kafka storage, they project it to the other side so they can use the projected state to make decisions. Oh dear. After some time in production, they number one problems. And the slide that goes on and on and on and on. And they say there are a shit ton of issues that we experienced with a system like that. I could argue that part of the issues they found and they faced, they are not actually natural to event sourcing because they used classic stack. That's one of the reasons. But might be some things that are kind of known issues up front by people who are doing it for a living, they didn't know about. They just discovered themselves. So they basically went to the minefield where some people with mine detector already passed through, or they actually lay down there on this minefield. The field took their life, but they kind of paved the path for the others. But they decided, okay, we go a different way. They find our own, and they step on new mines and hit them. So I'm sorry, this is probably a bad time to make jokes like this. And then they write a blog post. And there are quite a lot of them saying, yeah, really, like, don't do it. Because we tried, and we failed. And that's the thing, right? It's underwhelmed, event sourcing, overwhelmed, underwhelmed, or sometimes it's overwhelmed. So people just, either don't see the value because they do it wrong, and or they do it wrong, seeing the value, and still fail because it seems to be too hard. There are very little number of things about event sourcing that are conceptually hard to understand, hard to grasp, or hard to implement. The problem comes exactly on production day, or day N+1 day, where you roll out everything, you kind of tested it, everything seemed to work, and all is fine. But then you basically hit all the things, right? Do you know what the things could be? Ignoring the classic stack thing, that's kind of a different sort of problems.
Versioning?
Well, versioning, in my opinion, it's not a big issue. Like, it's very basic things. Like the API called querying things is returning stale data. And they haven't noticed it in the test because they were just manually passing through, or they say, okay, we just put a delay there. Or they never test queries in combination with command execution. Right? They test them separately. Commands execute properly, then we execute query tests maybe in like a second batch, and they're all fine because they took time to project. The long streams issue, right? If you don't use classic stack and use proper tooling, then if your entity is long-living and it has a lot of mutations because your design is not exactly optimal, you might get long streams and it starts to take time to read the streams, and it actually increases with time. And this increase never ends until you do something with it. Either you redesign your system or you basically introduce some technical concept like snapshotting. Talking to event store customers like on a weekly basis, and Eve talked to them on almost daily basis, we learn about bizarre scenarios when people using proper tooling, like we consider our database a proper one, still shoot themselves in the foot relatively often. And they ask us for help, or they blame our product for their own failures. So sometimes it is. So I wrote a book years ago. It's pretty old. The code is heavily obsolete, and I wouldn't write it this way again. But some people, maybe some in this room, read this book and say, okay, it helped me understand event sourcing and how I actually do it. The aim for this book was to explain people first, like concepts of domain redesign and kind of undercover because you don't see event sourcing in the title, right? I wrote it like it's event sourcing book in disguise. From chapter 10 onwards, everything is event sourced, and I created a set of things that people could use with little modification in production to build actually production-grade event source systems. And some do. So, yeah, it's easy. I described it in the book. So some simple start. I go into this repository. So anyone knows what it is? This repo? m/r, infamous. It previously was called simplest possible thing. Probably Greg reconsidered after a while, said probably that's not the simplest possible thing, but it's simple enough. And there were artifacts here like, what's it called? Sheeted database, I think, that was there. You remember? It's not there anymore, which is cool. So it's a bit more polite. There is one thing in this repository which is called infrastructure core. Don't bother reading, it's not important. And Greg, on his class, always complained that's the first thing people look into. And he considered this as a mistake. Because really, if you want to learn event sourcing, you look at everything else. But if you're going to build an event source system, that's the right place to look. Because it hides some of the complexity that nobody wants to talk about. And it's like not that small file, actually. And that's quite simple stuff, right? It's not production grade. Never use it in production. I dare you. But it's old, of course. It could be more optimized today. And it does something like the language does today, the C# language, like pattern matching and stuff. And it's not real because there is an event bus, right? You wouldn't use event bus in production application for sourcing projections because you would read from event store. And if you have a event store or something, you would need an infrastructure piece to work with the store. So you need an abstraction probably. So you may be switching from Postgres event store to event store DB in some time if you just grow and stuff. You start to build things like, okay, command handlers, but what on top of command handlers? I need an API and stuff like that. And I need a bunch of other things for production-grade applications. And what the things could be, where is my slide deck? That's where I started. It's chapter 10, so it's also simple stuff, right? It could be a replacement for MNR. It has just a few files. Chapter 13, fast forward, it's like this, and that's not including infrastructure bit. And it's not full, like the list that goes on, I just didn't want to overwhelm. And that is just a set of abstractions that I find necessary to execute things like, building a proper event source system. Infrastructure is another folder and has equal number of files. Because everything here, which is an abstraction talking to the actual databases and stuff, needs support as implementation of the abstraction. Oh, here it is. It grows from like 5, 10 files quickly to 20, 30. And then after some time, after 6 months, this is our ABAX infamous framework, which I built with a friend of mine, Sergio, who is very good at event sourcing. He worked with people like Iran Hout, Damon Hickey, eVision, and worked for us for quite a while. We built that together, and what do we need to do? Okay, we need to have a sort of the basic set of abstractions. It's not even shown here because the list is way too long. It's maybe 70% of all projects we have in that framework thing. And then we started adding things. So what do we need? In order to store events to event store, we need support of working with a client of event store DB or any other event store you use. we need to handle serialization and deserialization. And it doesn't necessarily need to be JSON. So you might provide people freedom to use serialization protocol they choose. One of the issues that I often talk about, just people who know, they consider it like it's for granted, you can't do it otherwise. People who start, they always make this mistake. Schema registry, aka type mapping. You don't want your fully qualified type name as an event type in event store, because as soon as you refactor, everything breaks. You can't deserialize it anymore. Simple things. And then you say, okay, for production-grade application, I need to have proper observability. And what a lot of people don't understand, even the monolithic event source system is essentially asynchronous messaging, which is distributed, or it's not distributed really, but it's composed of distributed components inside the application. For example, you produce events on a command side, they get written to event store, and you pick them up on the other side using subscription to event store to project your read models to implement CQRS. So you don't have it in one process, you actually have it going through the infrastructure. Which means you have stale data for some time in the read model. There are ways to mitigate this anyway. And what you actually need to do is to measure how stale your data is. So the first SLA you need to define for your query side of the event source system is how stale I can tolerate the data to be. In some systems it could be an hour, in some systems it could be like just 10 milliseconds. And that's the most important metric to watch and fix if there is an issue about it, because user will see something else, right? And if you go in production without this metric in place, and then the next thing is, of course, like, okay, I have quite a bunch of projections, like 10 of them. One projects to Mongo. They're all use case specific. I did a great job. I produced tons of them. One goes to Elastic. How do you know if all of them work? How do you know how much individual subscription actually behave? Like what time it takes to write to the database? Is it in trouble? Do I need to start optimizing it? You need to introduce things like more metrics maybe, but also distributed tracing. So you need to pass the trace metadata to the event, store it with the event, pick it up on another side, reconstruct the tracer context, and start tracing it on that side, because it's distribution. It's remote context now, even if it's the same application. And then you end up with things like this. gRPC, JSON, protobuf, message broker support, like we use mass transit, observability bits, metrics bits, support for Google storage, whatever, event store DB, the hosting bit, because you want the developers to start building applications faster so they don't write a lot of bootstrap code. And apparently you get 50 projects. That's another example I didn't want to share who that is. We ended up with exactly the same. So what happens next? So your company built a set of tools to support your production-grade event source systems and spent about 6 or 3 months writing it, if you're lucky, if you know what you're doing. And then during the application development lifecycle, you continuously improve it because you hit all the new issues, right? And then the champion for event sourcing eventually leaves the company. What happens then? Anyone experience that? Well, I heard stories that the whole bloody thing is too complex, we need to rewrite it back to SQL. Right? People actually did this. It's the same with, I was on an Isaac talk yesterday about F#. Like, I heard stories that when I left the company and I had a bunch of beautiful F# code people rewrote on C# on day 3, at least started the project. People are ready to invest in something that, to replace something they don't understand in order to build something they actually can get a grasp of. Because if you're building this kind of framework, usually it's not documented. None of this code was ever documented because we don't have time to write documentation. The code is documentation. It's easy, it's just a bloody left folder. How hard could it be? Yeah, appears to be pretty hard. You can do it, you will probably fail, and then you write a blog post. So the story about do we need event sourcing framework or not is kind of, yes, it has two sides. I talked to Dennis yesterday, and he said, of course you don't, because you have different use cases. But he also said another thing. It's like, for me, it's like almost a default. I can make a choice. It's just a tool in my toolbox. I know how to do it. I can write it with my eyes closed. Everything from scratch in the new company in a week. You didn't say this, but I assumed, okay? Yeah. Oh, maybe two, okay? Or you just bring the code with you, right? The question is what happens with Dennis leaves, right? Because he probably leaves better documentation than I did. Maybe not. So this question was asked by a fellow engineer when I asked them, okay, shall we try to do messaging instead of using raw RabbitMQ client? We will use mass transit because we can do things faster, right? You can skip the bootstrapping, exchanges and queues will be created for you. Say, why can't we use this? Look at your code. It's very basic. It fails all the time. So it's basically quite bad. It uses raw and RabbitMQ client, and you have 10% of the features mass transit has. Because there are people behind mass transit that basically did it for a living. Then Chris stopped coding on his current job, but he codes just for fun, you know. He's very smart. He receives input from multiple sources. People using his library in production has 72 or 62 million downloads on NuGet, which is a very high usage level. And the library continuously evolves to accommodate new infrastructure pieces, to make things easier, to integrate with bloody .NET 6, because like, okay, we integrated with .NET Core 2.2, and suddenly like we need to change everything again. And we just finished the migration from .NET Framework 4.6. Right? So are you going to do that work? What about retries? What about infrastructure maintenance? What about the poison message queues? What about dead letter queues? But then you just start using a library or framework with consequences. Because, for example, mass transit has opinions about how a message routing should happen. They route based on a fully qualified class name. As soon as you refactor your class name, your routing stops working because messages go to a completely different exchange, which has no binding because nobody else knows that you renamed the class until they updated your code with a new name. So I find it's like acceptable compromise, but I don't use mass transit as much anymore. If you decide to build your own thing using kind of basic things like ADO.NET, build your own ORM tool, use RabbitMQ clients, you will end up with like this. Half-assed messaging framework if you use RabbitMQ, because unavoidably you will create a set of abstractions because you make your application testable. You want to take over some of the burden of doing things all over again. Because there are quite a few of them, like creating queues and bindings and stuff like that. So okay, I create if you're good, right? If you're not good, you will not build anything, but it will be even harder to use. Because that's not your job. You work in companies that provide value to their customers. It's not your job unless you work in Axon to build frameworks. If you work in Axon, that's their product. Of course, they need to build a framework because they work for their customers. But if you're doing stuff like insurance, banking, and stuff like that, you might have a platform team, if you're lucky, that can provide you tooling, which is based on their limited capacity and knowledge, because they still work in a bubble. The only input they get about the quality of the libraries they produce is the company itself, unless they actually go wild and maybe open source it. Like, the reason why a lot of big tech open source their products is not because they're generous and they want to support open source. It's because they want to increase adoption of their tools, and they want other people to fix bugs for them, and maybe discover new ideas in their products, like happened with Kafka. People who built Kafka in LinkedIn never, in wildest dreams, thought that it would be a classic stack for event sourcing. But it happened. Because people are creative, right? Good or bad sides, so this went pretty hardcore, hence this, right? But on the other hand, there are brilliant things happening with tools like Spark, whatever, a bunch of things that were originally built inside and brought outside. But unfortunately, in .NET space, it doesn't happen that often. So when you start building production-grade event source system, understanding the concept, because that's the first thing you need to do, you want to hit a strike. I'm good now. I know what to do. I read a lot of blog articles. I know the hard parts because I learned that I read that one too. And you might need some letters because you need to be humble enough to say, accept the fact. Because I did the same mistake. Like I went to the course of Greg. Like, what could stop me possibly? Like, I know everything. It's very easy. It's just a bloody left fold. And then developers hated me for this. So that's what I try to do. I can't keep calm. I got fed up, and I say, okay, I'm going to do it, right? And I build this. It's a bit of demo time. The aim with this effort is to build an open source, maintained set of libraries, and maybe you can call it a framework, because some pieces of this could be considered framework. And I called it, if you look at my GitHub repository, in here, it used to say very opinionated, and just yesterday I changed this README file to say somewhat opinionated. The reason for that is that when you try to build something, like in the beginning, it's very opinionated because you implement like the main path that you see as a happy path. And this happy path is yours, and it's always opinionated. The more people start using your stuff, they provide inputs, like I said, open source internal stuff. This was not internal, never. It's always free open source. And then they actually change opinions, or I provide alternative ways of doing the same things. So it becomes less and less opinionated with time. And that's my aim, basically, not to lock people down. Of course, guardrails are important. Say, this is how you probably want to do it. But if you go further in your journey long enough, you will learn that certain things can be done differently. And that's what you would prefer. Because right now, the code is heavily DDD-oriented with concepts like aggregates, right? Some people, like Oscar, from our former colleague, you know him, he writes a lot about event sourcing. And he maintains model, and he says, okay, I don't like aggregates. Why? Yeah, because you don't need them. Okay, that I can agree. I don't agree that you don't like them, you don't need them, that I agree upon, right? I find them useful. That's why the first thing I implemented was using aggregates, and it still does. But I consider that I could do things like he wants to do. Left fold of commands to state or to event stream producing new events, right? Which is a more functional way of doing things, referring to yesterday of Shout Talk. You can actually do it. It has not been implemented yet, but I will do it. It's very easy to do, actually. So, and this thing is documented in a way that I heard more than one person. I don't have a lot of usage, but it's pretty popular. Some people don't admit it. Say, I read your docs, and I find I understood what event sourcing is. Probably he never read my book, but nevertheless. Because I have things like this. Some introduction, it's not that important because it's basically talking about the library itself, but I have articles like this. The right way. This is what I mean by guardrails. Like, I set up a frame how things should be built, regardless which code you use, actually. And that is heavily different from the diagrams I showed you before, right? Like, I think this is the classic stack. I mean, if you ignore the tooling, this is how things should go. And that's what I say. I'm humble enough saying, like, you can say I'm not humble enough because I call myself us. But I mean, I'm not alone in terms of there are not that many people building code, but there are quite a lot of people contributing in ideas and discussions and issues and stuff like that. So we talk a lot. In Airbox, there are people using it. So I refer to a group of people. It's not just me. But we are humble enough to say, according to us, this is the right way. It's like, I don't want to be dogmatic. So if you want to go with classic stack, off you go. Come to me later, we talk. And this thing, like Evil Bastard, I tried to have it a bit funny. I was thinking like people use event bus so often. They persist events to some database and then they publish them in two-phase commit and they lose them. It's like, and they always use event bus. That's not, I was searching evil bus or bus and fire and I found this. I think it's very good. It's not it's not easy to correlate like the event bus, classical, you just see a pipe, right, with this bus, but the word is the same, right? And it has quite a lot of documentation about the concepts and not that much about implementation, which is kind of sad, but I think it's enough. And I have 2 sample apps which show how it's supposed to be. So the aim of the thing, okay, if you knew, you got a concept, you probably read my prologue and say, okay, I know how to do it the right way. You got a confirmation bias, Spike not really into a system because you like what I write. You probably read my book before or not, whatever, you listen to my talks. I'm gonna use this. And if you do, the library, basically the Eventuous core is a library, it's not a framework, provides you with enough tools to actually bootstrap your applications pretty fast. I can show you how it looks. Let's see the value object. Where is my stuff? Well, it's nowhere to be found because I don't use value object interface or anything. This shit is rubbish. I mean, it's just like, don't do that. We have records. I mean, they're not ideal, but they're usable. So you can argue, okay, I can create my base class that will compare reference type by value as well. Or maybe you just use F#. We'll probably find a way to integrate it, but nevertheless, simple thing. If you go with simple things, create primitives, but you don't need my stuff to do it because you can do it yourself. When it comes to this thing, events. Here you see my stuff. But this is just a syntactic sugar. I added this annotation because people were complaining they need to register the event types in the mapping dictionary upfront, and they forget the application crashes at runtime. So I say, okay, I introduce an attribute, you can annotate it here, but I kept the previous possibility. So I didn't replace it, and that's why the framework becomes, or library, less and less opinionated, because there are multiple ways of doing the same thing. And people got a habit, okay, I declare a new event, I just attribute it with, because you see it as an example, right? You see someone wrote an event, annotated with type, and I will do the same. If you put it in another place, in a startup file, people would probably not notice. So this is a way to expose things. But it's still very simple. This one I use because I need the base class for it, unfortunately. But it's very easy. It just has a value. And this is my, let's look at aggregate first. This is the thing, right? So my aggregate has a state, which I will show you in a moment. And it has these operations. And it emits events. So, I mean, is it hard? Probably not that hard, right? You just say, okay, I want to ensure that, this is kind of not good, but ensure that my aggregate doesn't exist yet. Because if you create or you book a room, there should be no booking with this ID from before. Then you ensure that the room exists. Then you calculate the outstanding amount, because they might prepay a bit, and you emit an event. Or you apply an event. And there is a little, basically this is your code. There is nothing here that except of ensure exists or not exists and apply, which is the code provided by the library. Now this is a typical code for event-sourced applications in C#, no matter what you use. If you build your own, you probably end up with something like this. And then let's look at the states. And basically here I describe how, when I get this event in my state, how I modify the state. How many people have done it like this? What the rest of you doing with event source system? I mean, you read your events from the stream and say, okay, reconstruct the state, this is what you get. I mean, you don't need a dictionary for that. Again, like being less opinionated, you can basically override the when method and do the pattern matching there. The dictionary gives you a bit of predictability, so you can look at one place to see all the event handlers registered. And you can separate them by, like, you know, You can even move them to a separate file if you want, like some legacy events about versioning. Don't version, create new event, move the handler somewhere else, but keep it in code. Maybe the easiest thing. The aggregate state is a record, so it's immutable. You always can compare the state before and after executing the command, which is pretty cool. Sometimes it's very helpful. It's not hard, I'd say. I mean, I see a bit of confusion, but it's very small amount of code. And if I remove line breaks here, it would be even smaller, right? So the whole thing would be pretty small. But there is some wiring behind the scenes which puts the new events to the changes dictionary. It's when the aggregate state gets, or the aggregate gets stored in the store, the events get serialized, populated with tracing metadata, and puts in the right place at the right time. So it's all being handled. And let's look at the bootstrap, which is probably important. It's like how I can bootstrap the thing. And this is one of the foundational principles of Adventures. Like, first one is build what you use in production. That's why Postgres implementation, Microsoft SQL Server implementation of event storage subscription aren't mine. They're contributions, because I wouldn't do that in production. Second thing is don't fight the framework. So I work with .NET, new versions, newest versions. I adopt new features. And okay, ASP.NET Core, they want us to use dependency injection container, so fuck it, I mean, I will use it too. Because as soon as I start to fight this, developer will resist, because they used to do the things this way. Right? It's documented by Microsoft, they describe it as a default way to go, and as soon as I provide prescriptions myself, I kind of couldn't find Microsoft, or like, how could I tell Microsoft don't provide prescriptions? Because that they think it's the right thing to do, right? And I'm not fighting with them, I'm just going with the flow. Basically, to make this whole system work, you need the client, you need aggregate store, application service optional, these are domain services, and everything else is about integration and read-side projections. Read-side projections are pretty hard to do because you require checkpoint store, because you need to store the checkpoint somewhere. You require event handling, you require subscription management, like when you receive an event, how many handlers I have. Do you have one per subscription or more? You probably need more with a single checkpoint. What happens if the event handler fails? What happens if it's just too slow? How I can make it more reliable? How I can bloody trace it? Because there are all of things coming together when you talk in production. Good news, it's all being taken care of. So if I look at this projection, and I have for MongoDB, I just find it easier to create a bunch of extensions. None of them are kind of obligatory to use. And say, okay, when you receive room booked, it's a big one, I can show you later, but if the payment's recorded, I want to update one document using the default ID, which will use aggregate ID from the stream and use it as a document ID, and update that one field, right? It's pretty easy, but you don't have to use it. But you probably want to implement an event handler, which is Mongo projection implements an event handler. You can do your own. And I will take care about checkpointing, reading it, starting your subscription, shutting it down gracefully, storing your checkpoint at the right time in the right place. And if I look how it works here, hopefully it does. So it's 50-51. Yeah. So the API is exposing commands directly. It's your choice to do it or not. And through the HTTP, I have a helper method basically converting your commands to an HTTP endpoint. Some people really love it. Some people hate it, it's doing too much, becoming a framework. Now let's say I have a booking 234, and I have a guest ID, whatever, Alexey. room ID, room, and let's do it for 1 day. You know, I was doing the workshop, and it was end of February. And it didn't bloody work. And we were looking at this for like 15 minutes, and then we went for a lunch break, and during lunch break, someone said, Jesus Christ. 29th of February, good luck. Because it was 28th. Works once in 4 years, right? So it's not that expensive, and I have paid nothing, and I only accept some currencies, so this value object like demo, only accepting several currencies, otherwise it fails. Execute. So it was 200. I will show you later what it returns, but nevertheless, I can go now to my event store DB. Sorry, 2113. Go to stream browser. This is my booking, and this is my event, right? Everything worked, and you can see the tracing propagation here with trace ID, span ID, parent span ID, everything works. So it does quite a lot for you, but it doesn't look much. A lot of things happening behind the scenes, which I probably can talk about, but let's try something else. Just record a payment for this booking. Still have time. Was it 234, right? And I will pay 10 euros and payment will be payment 1 and paid my Alexey. So I execute it and then go here, stream browser, and payment recorded. It was pretty straightforward, nothing fancy. It's projecting to MongoDB at the same time, I believe. So if I go to Mongo Compass, while it starts, I will continue. So basically, the amount of code that you need to write to start application like this, and it's already like production grade. You need to test it and everything, but the infrastructure bit, which is hard, is being taken care of, and you have metrics, traces, logs, everything like that is taken care of. But that's not the only thing. Just see this one. Yeah, here we go. So there is a booking projection that creates basically representing the state. It's kind of rubbish, but it's for the demo. There is another one which is more interesting. It's basically taking 90 degrees or 180 degrees. Our CEO calls it turning database outside out. Because I don't use aggregate ID as a primary key for documents, I use the guest ID. And I create a new projection. If you go to my bookings page on booking.com, they don't have it. They have not that good system. But that's what I would do. I will create just a list of bookings by user ID and fetch it in no time because I don't need to query anything. Right? That's one of the powerful event sourcing features. But, okay, you use... I use a stream browser, and I project the state just to be able to look at it. The funny thing is that one of the promises of event sourcing is that it gives you a time machine. I heard about this. It's a time machine. You can go back and forth in time and see how your state changes. Have you seen your state changes in like time machine fashion ever in your life? Except of debugging, step debugging. I haven't, so I decided to build one. And that's a big day because I just finished building it, and the first time I show it in public, so bear with me, it might crash. And of course, I'm trying to be cool, so I use Blazor, which is probably not the right thing to do. Interesting thing is that when you have, when I have my set of abstractions and things kind of forced in your code, I can build an API that you can basically inject to your code that looks at the internals of your application and use them, if you want, and open an API on top of it. So I looked at what you have. I found a list of aggregates. If I add more, they will be scanned and shown on the screen, and say this aggregate has these functions: book room, record payment, make fully paid with S3, and ensure room available. by just looking at your code. And it has events applied to the state, room book, payment record, and booking fully paid. There are a couple of more events, but they just don't change the state, so I can find them. I think in the future I will be able to find them, but it needs a bit of like manual annotation, so you need to tell explicitly this is the events I want to be exposed in the list. And if I click on this one, and I say 2, 3, 4, it goes to your application. It uses your implementation of Event Store that could be Postgres, SQL Server, Event Store DB, but not Kafka, because Kafka is not an Event Store. It will figure out the aggregate ID. There is only one way to do it now, but I will change that. Well, you can do any stream name per aggregate in Eventus, but this Spyglass does it only one way, which is the default. I can read all your events from the stream. I can show you the payload, and I can reconstruct the state by, again, calling your code. I don't care what you can use protobuf, whatever, because I'm using your code. It's like I make a distinction. A lot of tools are looking outside in, trying to figure out, without knowing anything about your stuff, what happens in the application, just looking at observability data. I decided to go inside out because I know what's happening, because I have my set of abstractions, tools, and stuff like that, and I can call it if you just register my shit in the container, right? Because everything else is registered in the container. That's where container gets powerful, because you don't need wire dependency yourself. At time machine, right? So let's see. Outstanding amount 90 euros. Price is 100, and it's not paid. Let's go back in time. Yeah, outstanding amount 100 euros, and it's not paid, and stuff like that. So, what if I pay the full amount? Let's say booking is the same, paid amount is 90 euros, and it's payment 2, or 4, whatever. So it got executed. Let's see if I can reload it. Something happened. Of course, the minimum effect. I'm very glad that something worked. That's actually correct. I need to refresh maybe. 2, 3, 4. No, nothing works anymore. Something happens, of course. We'll just restart it. Trust me, I run it 100 times. And it always worked. And yeah, it works on my machine, right? It's like nothing works anymore at all. I'm so happy that something worked. So basically, after a bit of polishing, it will start to work. And the idea is that, okay, one of the powers of event sourcing that you can change how your state mutates in code, right? Because you don't store the state, you store events. You can change how your state gets reconstructed from events at any time, adding new properties and stuff like that. What you need to do, rerun your application, refresh the browser, and time machine will show you new state, right? Very cool, I think. And that's just the first step. There are a lot of things that you can extract if you provide these things, tooling inside the application that you can expose. For example, I can show you where your application service is and what aggregate it works with. I can show you that this command execution produces these events. And I handle a lot of hard stuff like the result stuff. You've been on the talk, Isaac's talk, and he said, don't throw, return the result object. That's exactly what I do. That also solves the UI issue. Like the UI is not getting updated because I need to read from the projection. It's not updated yet, it's stale. Like, don't do it. I returned you the new piece of state. You can just apply it to your UI side, right? If you use Blazor, you will just apply this bloody state object directly to your UI and you will see the rendered state. You don't need anything anymore. If you use more advanced stuff, like you can actually have your own projection in Blazor, for example, handling your events because it's the same bound context, you should do it as a monolith with the UI. So don't separate backend from frontend, just do it monolith. It's the same context. You can project these changes, which I return to you, these events, using the same contracts in the UI. It's like people say, okay, you can run internal projections to expose it through the API. You don't even need to expose it through the API. It's already exposed. I return you all the events that are being applied to this aggregate after the command execution, so you can directly change the UI as you see fit. Last bit before we start. Damien, Dennis is going to talk about optimizing projections, and I think we took a different approach. I'm very eager to learn what you've done, because one of the things happened to me is that, okay, you serialize your stream, right? You listen to all stream, global log, and you take an event, you project it. You take an event, you project it. You take an event, you project it, because you want this to happen. You can batch it, of course, but mainly it's like this. And if I always give people examples so they get it. If projecting one event to a SQL database take 5 milliseconds, how many events you can project per second? 200. Right? That's it. Round trip to the database takes 2 milliseconds. How many events you can project per second? 500. Yeah. It's a very hard limitation, because I work with systems that we ingest about 5 million events per day, just in a single, and it's businesses, right? It needs to be shown on the screen and stuff. So I built things. In particular, I built partition projections that partition the global stream in memory by the stream name. In many cases, it's like this. It's enough, but you can supply a custom partitioning function. And you can say concurrency level is now 10. I have 10 partitions. This is my partition function or stream name for partitioning. It goes 10 times faster almost if you target database control rate. I talked to one guy who was the first user of Ventures, and he said that was a game changer. On this optimistic note, I finished my talk, and I really want to see what you have done. Thank you very much. If you have questions,